Hey y'all, so in today's lesson, we're going to talk about how to actually carry out a hypothesis test using our lovely calculator website, and then how to write a conclusion to decide what that hypothesis test is telling me. So let's do that. So let's just recap real quick. What we talked about in our little intro lesson in 9.1 is just how we write null and alternate hypotheses. So what that would look like is for a means problem, which is what we're talking about today, your null is always going to be mu equals whatever number is the initial hypothesized version or number. And then your alternative or alternate, it'd be mu is less than, greater than, or not equal to from that same number. It must take one of these forms, and just remember that mu is the population mean, what we're hypothesizing about that population. So for example, Ms. Fitzgerald claims that the average for the class for the 6 weeks, the grade, is an 87. A sample of 15 students yields an average of 83 and a standard deviation of 5. So we want to know, is this sufficient evidence to claim or suggest that the class average is actually less than 87? So what we'd use for our null hypothesis, remember null is always that nothing changed, so that it's equal. So we would write our null is that mu equals 87 because that's what Ms. Fitzgerald claimed. Your alternate is what we think might be true or what we're trying to show is true. And in this case, they're trying to show that the average was actually less than 87. So mu is less than 87. So remember that those two numbers in your two hypothesis statements should be the same number. Just the null is that it's equal. The alternate is that it's less or greater or not equal. Another example, according to a survey done in 2000, found that girls who attended prom spent an average of $150 on prom night preparations. A recent study of 32 McNeil girls who attended prom spent an average of $160 with a standard deviation of 32. Is this evidence to suggest that the average amount on prom has increased? So again, your null is always equal. Mu is equal to something, and it's just whatever number was that initial assumption, the idea that nothing changed. So in this case, they're saying that that was the survey, so they think it's 150. So that's our null, mu equals 150. But at McNeil, right, we got an average of 160, and we want to show that evidence that the average has increased from 2000. So we think it's increased from 150, so our alternate would be that mu is greater than 150. And then last but not least, says the average GPA of Westwood High School students is 3.0. A random sample of 50 McNeil students found their average GPA to be 3.2 and their standard deviation to be 0.6. Is this evidence to say that McNeil students' GPAs are different from Westwood students? So in this case, again, null is always equal. So null would be whatever was that initial assumption, whatever we started off thinking. So that hypothesized value. So our null would be that mu equals 3.0. And then our alternate is what we're trying to show. And we're trying to show that McNeil students' GPAs are different. So our alternate would be mu is not equal to. So it just says different. It doesn't say greater than. It doesn't say less than. It says different. So we use that not equal to symbol. So now let's get into how we actually do these calculations. So I'm going to put all this stuff in here. And then I'm going to go show you. So we're using the same website, and I'll put the link to it, but it's the same website that we used in the last unit. But the difference is we are now doing a test instead of an estimate. An estimate is a confidence interval. A test means we're doing a hypothesis test. So I'm going to scroll all the way up here to the top where it says z-test of a mean and click that one. And then you have a bunch of things you need to fill in. So null hypothesis, mu equals. So remember that was our initial assumption. Then you're going to pick your alternate hypothesis. Are we trying to show mu is less than or greater than or not equal to? Then you'll put in details about the sample. So what was the mean? The symbol right here means standard deviation. And then n means the size of the sample, how many people or objects are in our sample. Once you've done all of that, at the very bottom will be your p-value. Remember, this is the probability of getting sample data like ours. It's the probability of seeing what we saw if the null were actually true. So we're going to do an example and actually do some interpreting in a second. after I explain something. So we use the p-value to determine if we have strong enough evidence to reject the null. The p-value is the calculated probability of getting sample results like we got. So if the p-value is small, we talked about this in the intro, the smaller the p-value, the more we're going to doubt the null hypothesis. So if the p-value is small, meaning a very small number, we are able to reject the null hypothesis. If the p-value is large, we are able or not able to reject. We fail to reject the null hypothesis is what we say. But how small is small? We say small and large, but at what, where's that boundary? So that boundary, kind of that line that kind of separates small from large, is known as the significance level, and we use alpha, which is another Greek letter. So typically, or sometimes you might be told in the problem what to use as your significance level. These are the common values, 0.1 or 0.05 or 0.01. If it's not stated, we go with 0.05. Basically, this number represents what's the difference between small and large. So if we get a p-value that's smaller than this number, than alpha, we say p-value is small, we reject the null hypothesis. If the p-value is greater than our alpha, we fail to reject the null. We don't doubt our null hypothesis. When p is small, reject the null. So I always like to use that it's a pseudo rhyme. It doesn't actually rhyme, but if you say it in kind of a British accent, it rhymes a little bit. When p is small, reject the null. Kind of rhymes. That was a bad British accent. I tried. So let's go back to example 1, which is about Miss Fitzgerald and the class average. So Miss Fitzgerald claims that the class average for this 6 weeks is an 87. A sample of 15 students got an average of 83. That was their sample average, and a standard deviation of 5. And we want to know, is that evidence to suggest that the class average is actually less than 87? So we already did our hypothesis statements. So what I could do is I could go to my little table and I could say my hypothesis, my null was that mu equals 87, because that's what Ms. Fitzgerald said, and that's kind of our initial hypothesis. But we think it's less because our sample average was an 83. So I'm going to pick null as 87. My alternate was that it was less. And again, that's what we did back on example 1, right? So, if I fill in the rest of my information, so my sample had 15 students in it, so that's the sample size, or n. The average of the sample was 83, and the standard deviation was 5. So if I fill that in, the average of the sample, or the mean of the sample, was 83, standard deviation was 5, n is 15 because there were 15 students in the sample. And that gives me at the very, very bottom a p-value of 0.001. So my p-value is 0.001. So remember, the rule is if p is small, reject the null. And what do we call small? Anything less than alpha. This problem did not give us alpha. So if they don't give you alpha or level of significance, we use 0.05. And 0.001 is definitely less than 0.05. So since our p-value, our probability, is smaller than 0.05, we can reject the null hypothesis. And if we're rejecting the null hypothesis, that means we do have evidence that the alternate is true. So all of this means that if it were true that the class average was 87, the probability that I would just randomly pick a group of 15 students whose average was an 83 is 0.001. In other words, that is really unlikely to happen by chance, Ms. Fitzgerald. I don't think you're telling the truth. I think the average was less than 87 because this would not have happened very easily. So that is our first example. So again, kind of some generic conclusions when you are writing your conclusion based on your p-value. So there are two things that could happen. If your p-value is less than alpha, whoops, I didn't fill this out. We say since our p-value of whatever is less than alpha, we are able to reject our null hypothesis, which means there is evidence that the alternative hypothesis could be true. And then if your p-value is greater, what we say is, since our p-value of whatever number is greater than alpha, we are not able to reject, we failed to reject the null hypothesis, which means there is not evidence that the alternate is true. So let's do another couple of examples. So back to example 2. Remember on example 2, right, we were saying mu equals 150 is the null, right, that girls spend $150 on prom. And then based on our sample, we are trying to show that the average is actually greater. So mu is greater than 150. So I'm going to go back to my calculator over here, and I'm going to type in. So my null was 150, and then I think it's greater. Now I'm going to put in my sample data. So it says 32 McNeil High School girls. That's our sample size. The average of the sample was 160. So the standard deviation was actually $38. So when I do that 38 as standard deviation, we get a p-value of 0.0683. So again, they didn't give us an alpha or a level of significance, so we use 0.05, and 0.0683 is larger than 0.05, which means that we cannot reject, we do not doubt our null hypothesis. In other words, this is not unlikely enough to happen for us to doubt. So we're not doubting the 150 is the true average. There's not evidence that the average amount spent on prom has increased. Right? In other words, our sample data is a little bit higher than our hypothesized data. 160 is a little bit higher than 150, but it's not higher enough for us to doubt that the 150 is true. Right? Remember, the 150 is about a population. The 160 came from a sample. Our sample data is always going to be a little bit off. So that's where all of this is coming from. All right, last example, back to the GPA question. So the average GPA of Westwood High School students is 3.0, and we think for McNeil it's different. Our hypothesis statements looked like that. So I'm having issues right now. Anyways, I don't know why it's showing all the answers, but I would put all that in my little calculator. So my mu is 3. My alternate hypothesis is not equal to. For our sample data, the average or mean was 3.2. The standard deviation was 0.6, and our sample size was 50. So if I put that in, it gives us a p-value of 0.0184. And so since that value is smaller than 0.05, we can reject the null. And that means that there is evidence of our alternate, which is that the GPA for McNeil is different from for Westwood, which is 3.0. So that is how we do a hypothesis test and write conclusions for it. So that is it for now, and we will discuss this in class next time.